let me try to explain some important concepts in the thermodynamics. Okay. So the first formula is here. The percentage of thermal efficiency of an engine is always equal to the percentage of the thermal efficiency of an engine is always equal to is the ratio of the output of the engine by the input of the engine. Output of the engine is nothing but the amount of work done, and the input of the engine is nothing but the amount of heat supply. So it is a ratio of the W by Q1 into 100. And you know, the Q1 is always equal to W plus Q2. Q1 is always equal to W plus Q2. This formula is valid for both the heat pump, for the engine as well as the refrigerator. So this concept, this equation is same for both the engine as well as for the refrigerator also. So Q1 is nothing but the amount of heat supplied to the engine. W is nothing but the amount of work done by the engine, and Q2 is the amount of heat which is rejected by the engine. So W, how can I write? W is equal to Q1 minus Q2. So Q1 minus Q2 by Q1 into 100. So if I simplify, what I am going to get? 1 minus Q2 by Q1 into 100. So these three are the general formulas which are applicable for both the reversible cycle engines as well as the irreversible cycle engines. Reversible cycle engines are also called as the ideal cycle engines or the Carnot cycle engines or the frictionless cycle engines. So this is a things you need to remember. So these three equations are valid for both the reversible engine cycles as well as the irreversible cycle engines. Reversible means frictionless, irreversible means friction is there. Okay? So now, suppose if you want to write the equation for only reversible cycle engines or the Carnot cycle engines or the ideal cycle engines or frictionless cycle engines, then what you have to do is, then in that case only we can write the Q in terms of temperature. Means heat you can write in terms of temperature only for that case. Okay? Only for reversible case. Only for reversible case. So therefore I can write Q in terms of T, which is Q is equal to K into T. So where K is a constant and Q is the heat and T is the temperature in Kelvin. See, T is always in temperature in always Kelvin. So if you want Q1 is nothing but K into T1. If you want Q2 means K into T2. So K cancels, we are going to get 1 minus Q2 by T1 into 100. So this is the expression of the thermal efficiency of the reversible cycle engines or the frictionless cycle engines or the ideal cycle engines or the Carnot cycle engines. Okay. So if you see clearly, the thermal efficiency is depending only on the temperature limits. Only on the temperature limits. Where T is called as a temperature and temperature is always in terms of the Kelvin. Whenever you deal with the concepts of thermodynamics, you need to keep in your mind that always the temperatures are in terms of the Kelvin only. So here, basically, T1 is the source temperature. Same is the source temperature, or it is also called as the initial temperature, or it is also called as the inlet temperature. Okay? Or we can also call it as the temperature of the higher temperature reservoir. Okay? Whereas T2 it is called as a sink temperature, or it is also called as the outlet temperature. It is also called as the temperature of the lower temperature reservoir. So these are the different names. So T1 is always greater than the T2. Okay? Suppose in the question if they are given the temperature in degrees Celsius, and if you want to convert into Kelvin, just you need to add 273 for the degrees Celsius in order to convert into Kelvin. So that temperature in Kelvin is equal to temperature in degrees Celsius plus 273. So I request you to remember this one. Okay? So now the next concept is I'll try to discuss about the types of systems. Basically, there are 3 types of systems which are nothing but open system, closed system, and the isolated system. In the case of open system, the mass as well as energy are going to transfer the boundary. Okay? In the case of closed system, only energy is going to transfer the boundary but not the mass. In the case of isolated system, neither the mass or nor the energy are transferred to the boundary. Means in simple words, I can say in the case of open system, both the mass as well as energy are going to transfer the boundary. In the case of closed system, only energy is going to transfer the boundary but not the mass. In the case of isolated system, both the mass and energy are not going to transfer the boundary. We can also call it as neither the mass nor the energy transfer the boundary. So this is the thing you need to always keep in your mind. So T means transfer, plus means not transfer. Okay, this is a very, very important thing. Always you have to keep in your mind. And what is boundary? Boundary is a line which is going to separate the system as well as the surrounding. Let's say the system means it is inside the boundary and surrounding means outside the boundary. So whenever you do the combination of the system as well as surrounding, then we are going to get the universe. So whenever you are going to combine the system as well as surrounding, then you are going to get the universe. So this is a point you need to keep in your mind. So now, this is a very important equation in the case of the first law of the thermodynamics. So this is a very, very important equation in the case of the first law of thermodynamics. It is nothing but dq is equal to du plus dw. What is dq? The amount of heat transfer. What is du? du is nothing but the change in internal energy. And what is dw? Amount of work done. So always, this is a basic equation in the case of the first law of the thermodynamics. So basically, the first law of thermodynamics was the principle of the law of conservation of energy. Because whatever input energy we are going to transfer into other categories, means energy we are transferring from one form to another form, but overall the energy is concerned. Whatever the heat that we are going to transfer to the piston cylinder, it is used to for increasing the internal energy of the gas molecules as well as doing some of the work. So that is the reason the energy is conserved. So dq is du plus dw. But this is a sign sensitive equation. So you have to keep the values of dq, du, dw with the sign. You need to keep with sign. So what is those things we will discuss now. If Q is equal to positive means heat is supplied to the system. Whenever the heat is supplied to the system means Q is positive. And Q is equal to negative means heat is rejected by the system or heat is lost by the system. Okay. U is equal to positive means increase in internal energy. U is equal to negative means decrease in internal energy. W is equal to positive means work is done by the system. That is called as the expansion mode. Work is equal to negative means work is done on the system. That is compression mode. So that you should be very, very careful while putting the values in this equation because these are the sign sensitive. So Q is equal to positive means heat is supplied to the system. Q is equal to negative means heat is rejected by the system. U is equal to positive means increasing the internal energy. And U is equal to negative means decreasing the internal energy. And W is equal to positive means work is done by the system. That is nothing but expansion work. And W is equal to negative means work is done on the system. That is compression work. Then you should be very, very careful regarding all these things. You should keep with the sign sensitive. Okay. Now let's go for the other concept. Now I am going to tell you regarding the relation between the CP as well as CP. I will try to give some formulas of the CP as well as CV in a very detailed manner. What is CP? CP is called as the specific heat at the constant pressure. And what is CV? Specific heat at the constant volume. And what is gamma? Adiabatic index, and its value is always greater than 1. And what is R? R is called as the characteristic gas constant, or sometimes people used to call it as the ideal gas constant or simply gas constant also. So CP means specific heat at the constant pressure, and CV means specific heat at the constant volume, and gamma means adiabatic index, and its value is always greater than 1. And R is called as the characteristic gas constant or the ideal gas constant or simply gas constant. So I request you to remember these three basic formulas. CP minus CV is always equal to R. CP minus CV is always equal to R. And CP by CV is always equal to gamma. Okay. So I have already told you gamma value is always greater than 1. So by default I can say CP is always greater than CV. Okay. So I request you to remember these two things. Okay. CP minus CV is equal to R. And CP by CV is equal to gamma. CP minus CV is equal to R. And CP by CV is equal to gamma. The CP is called as the specific heat at the constant pressure. CV is the specific heat at the constant volume. And gamma is the adiabatic index, and its value is always greater than 1. And R is called as the characteristic gas constant or the ideal gas constant or the simple gas constant. So CP minus CV is equal to R. CP by CV is equal to gamma. CP is always greater than CV. So if you try to simplify these two equations, then we are going to get the value of CP as well as CV, which is nothing but CP is equal to gamma into R by gamma minus 1. CV is equal to R by gamma minus 1. So if you know these two basic equations, you just simplify, you will get these two things. Okay. It's a very, very important concept. Definitely one question will be coming from this concept. So now the next concept is about the types of process. So we'll discuss the important types of, now I'm going to discuss about the types of process in the case of the thermodynamics. So basically we have 5 types of process in the case of the thermodynamics. That is nothing but constant volume process, constant pressure process, constant temperature process, constant heat process, and polytropic process. So these are the 5 processes which are going to present in the case of the thermodynamics, which is the constant volume process, constant pressure process, constant temperature process, constant heat process and the polytropic process. Constant volume process is also called as the isochoric process. Constant pressure process is also called as the isobaric process. Constant temperature process is also called as the isothermal process. And the constant heat process is also called as the isentropic process or the reversible adiabatic process. Okay. Polytropic process is also called as the general law of expansion. So, constant volume process is also called as the isochoric process. Constant pressure process is also called as the isobaric process. Constant temperature process is also called as the isothermal process. Constant heat process is also called as the isentropic process or also reversible adiabatic process. And polytropic process is also called as the general law of the expansion. So now, for each and every process, I will try to give the expression or the equation I will try to give you. So remember the basic equation PV is equal to nRT. P means pressure, V means volume, N means amount of substance, R means characteristic gas constant or ideal gas constant, simply gas constant. T means temperature. Temperature is always in terms of Kelvin. Whenever you see temperature, in the case of thermodynamics, try to keep it in the Kelvin only. So now, in the case of constant volume, volume is constant. So definitely volume is constant, then definitely P is directly proportional to temperature. So P is directly proportional to temperature. In the case of constant pressure, the pressure is constant. If pressure is constant, definitely volume is directly proportional to temperature. So volume is directly proportional to temperature. In the case of the constant temperature process, it indicates that temperature is constant. So by default, PV is equal to constant. So PV is equal to constant, right? So these three equations we can easily get with the help of the PV is equal to nRT. So N into R is nothing but I am going to assume both are constant. So I can assume it as a K also. N into R, I will try to assume it as a K. And K is constant, N is constant, and R is constant. Okay. So now let's go for the constant heat process. In the case of constant heat process, I've already told you. Suppose you take a piston cylinder. You try to make a piston cylinder, and you try to compress the cylinder. Try to compress the piston inward. Then what is going to happen? The volume of the air molecules is going to get decreased. If the volume decreases, pressure will increase and temperature will increase. So therefore, what I can say that pressure is directly proportional to temperature and it is directly proportional to 1 by V. So you can see pressure and temperature are directly proportional and both are inversely proportional to volume. So pressure and temperature are directly proportional and they are inversely proportional to volume. I've already told you, whenever you compress the air, the volume will decrease, but the pressure and temperature will increase. Okay, that is the reason pressure and temperature are always directly proportional and both are inversely proportional to volume. But you need to remember the powers. For this power, this power values you need to keep in your mind. For pressure, the power is 1 by gamma, and for temperature, the power is 1 by gamma minus 1, and for volume, the power is 1. Okay, this is a very, very important thing. Always you have to keep in mind. So for pressure, the power is 1 by gamma, and for temperature, the power is 1 by gamma minus 1, and for volume, the power is 1. Suppose now, if you want to, for the next polytropic process, now I want to tell you what is the equation. So just in this, in place of gamma, in the previous equation, in the place of gamma, just replace gamma by N. That's it. Then you are going to get this equation. It's the same equation, but the only thing is I have replaced gamma by N. Then I have got this one. Okay. This is a point you need to keep in your mind. So now, what is the meaning of N? N means basically the slope. N means something that is a slope of the graph, of the PV graph. N is something that the slope of the PV graph. P is on the y-axis and V is on the x-axis. So for a constant volume, you are going to get the vertical line. For a vertical line, what is the slope? Infinity. That is the reason N is equal to infinity for the constant volume process. For the constant pressure, if you draw the PV diagram, we are going to get a horizontal line. For horizontal line, what is the slope? It is nothing but 0. So these two things we can easily get from the help of the concept. The remaining things how to remember, let me tell you. So try to remember this last one. 1 less than N less than gamma. First what you are saying N, so keep it here 1. So first you are saying 1, so keep it here 1. Then you are saying gamma, keep it here gamma. That's it. For 1 less than N less than gamma. So first you are saying 1, so keep here 1. Then you are saying gamma, so keep it here. That's it. So this is the thing that you need to keep in your mind. So slope is equal to infinity for constant volume process. Slope is equal to 0 for constant pressure process. Slope is equal to 1 for constant temperature process. Slope is equal to gamma for constant heat process. And slope is going to lie between 1 to gamma for polytropic process. So this is the thing always you need to keep in your mind. So now The next concept that I am going to tell you is about the extensive property as well as the intensive property. Extensive property is also called as the extrinsic property. Extrinsic property. Basically, it is going to, these parameters are going to depend upon the mass. These parameters are going to depend upon the mass. What are the best examples? Mass as well as volume. See, volume is, as the volume changes, the mass is also going to get vary. The best example is laddu. I have already told you 5 kg laddu has more mass and more volume when compared to 2 kg laddu. So the volume and the mass of the 5 kg laddu is greater than the volume and mass of the 2 kg laddu. So therefore, as volume changes, mass is also going to get vary. So therefore, volume is going to get dependent on mass. So it comes under the extensive property. And also the energy. All the examples of energy like the enthalpy, entropy, kinetic energy, work energy, etc. So whenever you see any energy, by default they are going to come under the example of the extensive property. Now let's go for the intensive property. Intensive property is also called as the intrinsic property, and in this the parameters are independent of the mass. So what is the best way to remember? In the case of intensive, I is there. In the case of independent also, I is there. So therefore, these two things are same. So in the case of intensive property, the parameters in which they are independent of the mass, so that is called as the intensive property. So what is the best example? Density. Density is nothing but it is going to depend upon the mass per unit volume. See, suppose you take a density of steel. You take a density of steel is it will have some particular value, which is 7850. So it will have some amount of density per kg per meter cube. 7850 kg per meter cube means no matter how much mass you consider, still its density is always constant. Density is nothing but the amount of mass per unit value. No matter how much amount of mass you consider, still density value is same. So no matter how much amount of mass of steel you consider, still the density of steel is same. So therefore we can say density is independent of the mass. So therefore we can say this comes under the category of the intensive property. Pressure is going to depend only on the height, but it is independent of the mass. So it comes under the intensive property. Yes, temperature is also independent of the mass. So it is also comes under the category of the intensive property. And all the examples of the energy, but before that energy, you need to keep a specific. Yes, all the examples of the energy, all the examples of the extensive property, but before that you need to keep the specific. Then it comes under the intensive property. See, all the examples of extensive property, but before that you need to keep the specific, then they are going to become the examples of the intensive property. So all the examples of the extensive property, but before that you need to keep the specific, then you are going to get the examples of the intensive property. So what are the things? Specific energy means specific enthalpy, specific entropy, specific kinetic energy, specific potential energy, specific work energy, and specific mass, specific volume. So all these are the examples of the intensive property. Means if you take all the examples of extensive property and before that if you keep the specific, then they are going to become the examples of the intensive property, like specific mass, specific volume, specific energy mass, specific enthalpy, specific entropy, specific kinetic energy, specific potential energy, specific work energy, like that. So this is a concept that you always have to keep in your mind. So now let me try to explain the relation between the thermal efficiency, the coefficient of performance of the heat pump, and the coefficient of performance of the refrigerator. So between these three things, I want to give you a basic relations which are very, very important. This is called as the thermal efficiency, and this is called as the coefficient of performance of the heat pump, and this is called as the coefficient of performance of the refrigerator. So what is the thermal efficiency? I have already told you thermal efficiency of the engine is always equal to, it is a ratio of the output of the engine by the input of the engine. What is the output of the engine? The work done by the engine. What is the input of the engine? Which is nothing but the heat supplied to the engine. So W by Q1. And I have already told you Q1 is equal to W plus Q2. So W is equal to Q1 minus Q2. So therefore we are going to get Q1 minus Q2 by Q1. Okay. Now what is the coefficient of performance formula? Coefficient of performance is the ratio of the desired effect by work of completion of work. So the coefficient of performance means it is a ratio of the desired effect by the work of completion, means W. So denominator is work. Work means I'm already doing this Q1 minus Q2. So for heat pump, what is the desired effect? Heat, right? Heat, more heat is the desired effect for heat pump. What is the desired effect? More heat. Out of Q1 and Q2, which is having the more heat? Q1, because Q1 is a heat which is coming from source. So definitely it will have more amount of Q1, higher value. So keep here higher value. Q1 by Q1 minus Q2. Similarly, the coefficient of performance of the refrigerator is the ratio of the desired cooling effect by the work. Work is nothing but Q1 minus Q2. See, for the refrigerator, what is the desired effect? Cooling effect. So the Q1 and Q2, which is having the lower temperature Q2, so therefore you have to fit the Q2. So that is a very simple thing. So for heat pump, the desired effect is higher temperature. For refrigerator, the desired effect is less temperature. So out of Q1 and Q2, here Q1 is having higher temperature, so keep here Q1. Out of Q1 and Q2, Q2 is having lesser temperature, so keep here Q2. So these are things you need to keep in your mind. So if you know these three things, then we can get these two basic relations. The thermal efficiency into the coefficient of performance of the heat pump is always equal to 1. And the coefficient of performance of the heat pump minus coefficient of performance of the refrigerator is always equal to 1. So these two formulas always you need to keep in your mind. So the thermal efficiency into the coefficient of performance of the heat pump is always equal to 1. And the coefficient of the performance of the heat pump minus the coefficient of performance of the refrigerator is always equal to 1. So whatever thermal efficiency you are taking, always take in the numerical value in this case, but not in the percentage values. Take only in the case of the numerical values, because here only I have taken the numerical value only. Okay. So now let me tell you the laws which are going to present in the case of the thermodynamics. Basically, we have three laws in the case of the thermodynamics, which are nothing but zeroth law of thermodynamics, first law of the thermodynamics, and the second law of the thermodynamics. So zeroth law of thermodynamics, basically it talks about the temperature or the measurement of the temperature. It is going to work on the principle of the thermal equilibrium. Okay. Now the first law of thermodynamics, basically it talks about the energy, or it is going to work on the concept of the law of conservation of energy. There you can see the basic relation dq is equal to du plus dw. Okay. Now the second law of thermodynamics, basically it deals or talks about the entropy. And in this we have two statements. One is the Kelvin-Planck statement and the other is the Clausius statement. See, Kelvin-Planck statement told that you cannot design any engine which is having a 100% efficiency. Whereas the Clausius statement is like this, which is basically it is going to tell you how the heat flow is going to get happen. Whenever there is a temperature difference between the two bodies, then only heat transfer will happen. And naturally, the heat is going to transfer from higher temperature body to the lower temperature body. But in case if you want to transfer the heat from lower temperature body to higher temperature body, definitely you require some external work or external agency. These are some of the important points regarding the Clausius statement. So finally, let me repeat. In the case of thermodynamics, we have three important laws, which are nothing but zeroth law of thermodynamics, first law of thermodynamics, and the second law of thermodynamics. So zeroth law of thermodynamics, basically it deals or talks about the temperature or measurement of temperature on the thermometry, and it works on the principle of the thermal equilibrium. Whereas the first law of thermodynamics basically deals or talks about the energy or the law of conservation of energy. And in this we have seen the basic equation dq is equal to du plus dw. Whereas in the case of second law of thermodynamics, it is going to works or deals about the talks about the entropy. And in this we have two basic statements. One is the Kelvin-Planck statement and the other is the Clausius statement. So Kelvin-Planck statement it states that you cannot design any engine which is having the 100% efficiency. Whereas the Clausius statement is that it is going to tell you how the heat flow is going to happen. Means whenever there is a temperature difference between the two bodies, then the heat flow will happen. And naturally, the heat is going to flow from the high temperature body to the low temperature body. And also, which is if you want to transfer the heat from low temperature body to high temperature body, definitely you require some external work to be done on the process. Or the external agency must be required, then it will happen. Okay. So now let's go for the another concept, which is the cyclic integral. So this is a very important thing that you always have to keep in your mind. So what is the meaning of cyclic integral? This symbol is called cyclic integral. So when dq by the cyclic integral of dq by t, if it is less than 0, we say it is an irreversible cycle. The cyclic integral of dq by t, if it is equal to 0, we say it is a reversible cycle. When the cyclic integral of dq by t, if it is greater than 0, we say it is an impossible cycle. So how to remember this one is very simple. Try to assume a cyclic integral of dq by t as efficiency. So try to assume a cyclic integral of dq by t as the efficiency. Okay, and try to assume 0 as the 100%. So 0 as the 100%. What is the assumption? Assume that the cyclic integral of dq by t as the efficiency and assume 0 as the 100%. So now try to analyze. So now in the first case, efficiency is lesser than 100%. So what is the meaning of that term? If efficiency is lesser than 100% means by default we can say it is a practical one. For a practical one only, loss are going to get present. So practical is nothing but irreversible cycle. Okay. Now the second case is here the efficiency is equal to 100%. What is the meaning of efficiency is equal to 100%? It is an ideal. Ideal means we can say it is a reversible cycle. Okay. So now reversible means no friction means no losses. For the first case, irreversible it is also called as a friction is high. Means loss are there. Okay, that is the reason this comes under the practical category. So last one is here the efficiency is greater than 100%. Can you make any engine which is having efficiency of more than 100%? It is impossible. That is the reason we say it is a impossible cycle. Okay, this is the point you need to keep in your mind. So definitely you will get at least one question from this concept. So now, finally, this is very important statements. Always the area under the PV diagram is a gives you about the work transfer. The area under the PV diagram in the case of thermodynamic process, it tells about the work transfer, where P is called as the pressure and V is called as the volume. So area under the PV diagram in the case of the thermodynamic process tells you about the work transfer or work done, where P is the pressure and V is the volume. Similarly, the area under the PS diagram is going to tell me about the heat transfer. The area under the PS diagram in any thermodynamic process tells you about the heat transfer. P is nothing but temperature and this is called as the entropy. So area under the PS diagram basically it tells about the heat transfer. Where P is called as the temperature and this is called as the entropy. So these are the important formulas in the case of the thermodynamics.